The people Columbus met in 1492 had blood that was essentially 100% type O. 530 years later, Caribbean Hispanic blood donors returned the highest type O rate of any ethnic group in American blood bank data, 57%, compared to a global average of 39%. Those two facts are connected. The connection runs through ancient DNA extracted from pre-contact skeletons, through the specific colonial mechanism that extracted Taíno men to pearl beds and gold mines while preserving Taíno women on the islands, through the West African populations brought to the Caribbean who were already running above global O averages themselves, and through a founding event 15,000 years before any of that, when the first humans crossed from Siberia into the Americas carrying an O allele that had no competition. The global map of blood type distribution is not random. Blood type O is the most common type in the world, carried by nearly half of the global population, followed by A at 31%, B at 24%, and AB at roughly 6%. But those global numbers conceal an extreme regional pattern that most people never encounter. The countries with the highest type O rates in the world are Ecuador at 77%, Peru at 71%, and Nicaragua at 62%. What those countries share is the highest indigenous ancestry concentrations in Latin America. Nearly half of Caribbean country populations carry type O positive. Among admixed populations globally, populations formed from multiple ancestry sources, Caribbean Hispanics return the highest type O rate of any comparably mixed group on Earth. The metric that threw me for a loop during my initial research wasn't the peak. It was the global baseline. 39% feels like a lot for a single blood type. But when you see 57% next to it, you understand that something very specific is happening in Caribbean populations that is not happening anywhere else with the same demographic history. Following the reason for it required going back to a crossing that happened before any civilization had invented writing. Approximately 15,000 to 18,000 years ago, the first humans crossed from Siberia into the Americas through the Bering Land Bridge. The crossing was made by a small group carrying limited genetic diversity. This is the founder effect. When a small group separates from a larger population, the genetic variants they happen to carry become disproportionately represented in all the descendants that follow. The founding group that entered the Americas carried the O allele at high frequency. The A and B alleles, common in Europe, Asia, and Africa, were either absent or present at very low frequency in that founding group. The B allele is heavily concentrated in Central Asia and was entirely missing from the main migration to the Americas, which is why it is essentially absent in pre-contact indigenous populations of Central and South America. Over millennia of population growth in complete geographic isolation, the O allele became near universal across the Americas. While the A allele managed to persist in certain North American pockets, the pre-contact indigenous populations of Central and South America developed the most extreme type O concentration in global history. Indigenous populations of South and Central America showed type O frequency reaching 90 to 100% in isolated communities. Peru at 71% nationally. Ecuador at 77% nationally. These are national averages that include significant European and African admixture from the colonial period. The pre-contact indigenous populations were higher. The Taíno, the Arawakan-descended indigenous people of the Caribbean whose ancestral roots in South America the Schroeder et al. 2018 PNAS study confirmed through a 1,000-year-old genome from Preacher's Cave in the Bahamas, were carrying 95 to 100% type O by the time Columbus arrived. What the ancient DNA research settled for me specifically was the question of whether that high indigenous O frequency was something that existed before European contact, or whether it was a consequence of the population collapse that followed. Disease, war, and the colonial period reduced indigenous populations across the Americas dramatically. If the collapse selectively killed people with A and B blood types and left type O carriers disproportionately likely to survive, the current high O rate in indigenous populations could be a colonial era artifact rather than a pre-contact reality. That would change the entire explanation for the Caribbean's blood type distribution. Ancient DNA resolved the question directly. In 2008, Halverson and Bolnick published a study in the American Journal of Physical Anthropology that analyzed the ABO blood type genotypes of 15 pre-contact indigenous individuals from Eastern North America, people who died before any European contact. 14 of the 15 were homozygous for type O alleles. One individual carried a single A allele alongside an O allele. The paper concluded that the high frequency of blood type O, was present in indigenous populations long before European contact. The founder effect hypothesis was confirmed. The post-contact selection hypothesis was ruled out. A separate study examined 31 individuals from the southern Peruvian highlands, dating to approximately 650 to 1250 CE, centuries before Columbus reached the Caribbean. All 31 were exclusively type O. The Taíno contribution to Caribbean blood type distributions is therefore not an inference. Every Taíno ancestral lineage that passed into the modern Caribbean gene pool carried an O allele, not an A allele, and not a B allele, because 15,000 years of American isolation had established this as the near universal blood type across the entire hemisphere before any Spanish ship appeared on any horizon. How much of that Taíno inheritance actually survived into modern Caribbean populations is where Dr. Juan Carlos Martínez-Cruzado's research becomes essential. Martínez-Cruzado, a biologist at the University of Puerto Rico at Mayagüez, conducted a mitochondrial DNA study of 800 Puerto Ricans selected to represent the island's population, funded by the United States National Science Foundation. The study, published in 2005 in Human Biology, found maternal ancestries of 61.3% Amerindian, 27.2% Sub-Saharan African, and 11.5% West Eurasian. Mitochondrial DNA passes exclusively through the maternal line. The 61% Amerindian maternal signal in Puerto Rico reflects the women whose lineages survived, specifically the Taíno women who remained on the island while Taíno men were extracted to the pearl beds of Venezuela and the gold mines of Hispaniola. The colonial demographic system that dismantled the Taíno civilization inadvertently preserved the Taíno maternal line because it was the Taíno men who were transported and killed in the labor extraction economy. Those Taíno women's maternal lineages, carrying their near universal O alleles, passed forward through every generation of Puerto Rican ancestry that followed. 61% of Puerto Ricans carry a maternal haplogroup from an ancestral population that was essentially 100% type O. That maternal inheritance contributes O alleles at near maximum frequency regardless of what the autosomal ancestry percentage returns. The autosomal DNA figure, the 14% indigenous ancestry that DNA tests report for Puerto Rico, is the conservative measure. The actual blood type contribution from that Taíno lineage is disproportionately larger than the autosomal percentage implies. The piece of the puzzle I never anticipated uncovering was how the West African demographic data actually behaves. Most people would assume that the African ancestry in Caribbean populations pulls the O rate down, that African populations carry more A and B alleles than indigenous Americans, and that the Caribbean's high African ancestry component reduces the total O percentage from the indigenous baseline. The population genetics data runs in the opposite direction. Blood group O is the predominant type in Ghana at 54.7%. In Nigeria, study data shows type O at over 53% among donors. In Tanzania, type O reaches 52 to 55%. The specific West African ethnic groups that comprise the largest portion of the Caribbean slave trade, Yoruba from what is now Nigeria, Fon and Ewa from Benin, Akan, and Ashanti from Ghana, all show type O rates between 54 and 78%. These populations are significantly above the global average of 39% before they ever arrived in the Caribbean. When West African ancestry at 50 to 78% type O combines with Taíno indigenous ancestry at approximately 95 to 100% type O, the combined contribution to the Caribbean blood type pool is elevated by both ancestral sources simultaneously. The European ancestry component, Spanish and Canarian settlers who make up the largest share of Caribbean autosomal ancestry, contributes type O at approximately 45 to 47%, close to the global average. But in the blood type arithmetic, it is the minority contributor. Two ancestral sources, both carrying elevated O frequencies, are doing most of the work. The three-island differential follows from this arithmetic, and it runs through the same colonial mechanisms that produce different DNA ancestry profiles across the three islands. To understand how these numbers split, we have to look at the historical forces I documented in the video comparing Puerto Rico, Cuba, and the Dominican Republic. What we see in the blood type arithmetic is an exact reflection of those three distinct genomic profiles. The numbers diverge because the colonial economy required entirely different things from each island and at completely different times. Puerto Rico carries approximately 14% indigenous ancestry, 22% African, and 65% European. The indigenous component contributes at near 100% O. The African component contributes at 50 to 78% O. The European component contributes at 45% O. Puerto Rico's mountain interior preserved Taíno maternal lineages at concentrations above the island average. The Martínez-Cruzado finding of 61% Amerindian maternal ancestry confirms this. The blood type contribution from the Taíno lineage in Puerto Rico is therefore larger than its 14% autosomal representation would predict. The Dominican Republic carries approximately 9% indigenous ancestry, 39% African, and 52% European. The higher African proportion, concentrated from Fawn and Yu populations through the Saint-Domingue slave trade routes, with type O rates above 60% in those West African groups, compensates for the lower indigenous proportion. The Dominican Republic achieves its elevated O rate primarily through its African ancestry component. The mechanism is different from Puerto Rico's, but the direction is the same. Cuba carries approximately 6% indigenous ancestry, 20% African, and 72% European. The highest European proportion of the three islands pulls the O rate slightly lower than the other two. But Cuba's African ancestry, shaped by the Haitian Revolution's displacement of West African descended populations into Cuba after 1804, adding a Fawn and Yu dominant West African component, still contributes significantly above the European average. Cuba's O rate is the lowest of the three islands and still elevated above global norms. The 57% in American Blood Bank data reflects the combined result of all three island profiles measured together. Foreign-born Caribbean Hispanics return a higher O rate than U.S.-born Hispanics, 57.6 versus 52%. Each generation of admixture with non-Caribbean populations in the United States gradually reduces the high O ancestral signal that island-born populations preserved more intact. The further back toward the island, the higher the O frequency becomes. That 57% mark isn't some random biological quirk. It stands as the living imprint of a tiny band of Ice Age travelers crossing the Bering Strait millennia ago, whose specific genetic signature became the default template for an entire hemisphere. It is a legacy carried forward by indigenous women who endured a brutal colonial labor system that devastated their communities but spared their maternal lines, only to be reinforced centuries later by West African arrivals whose own high frequencies of the same allele consolidated the pattern rather than washing it away. The letter on a blood type card is not arbitrary. It carries a 15,000-year sentence whose first word was spoken at the Bering Land Bridge. If your roots trace back to the islands and your veins carry type O blood, you are looking at a 15,000-year inheritance. Hit that subscribe button. And if there is anyone in your household holding onto a donor card without realizing the epic history written into their biology, make sure they see this video. Thanks for watching.